Hello everyone. In this video, we will see the periodic noise reduction by frequency domain filtering in digital image processing. So the periodic noise, it appears in images as regular repeating patterns such as horizontal or vertical stripes, ripple-like patterns, interference bands, or concentrated burst of energy in the Fourier transform at locations corresponding to the frequencies of the periodic interference. This is one example of the image where it is affected by the periodic noise. Now, the periodic noise, it can be analyzed and filtered using the frequency domain techniques. And the approach here is to use the selective filter and to isolate the noise. Now, why we use the frequency domain filtering here instead of spatial domain filtering? Because in spatial domain filtering, the periodic noise or in the spatial domain, the periodic noise is very hard to remove because it blends with the image details. But in frequency domain, the periodic noise, it shows up as bright points or the peaks at specific frequencies in the Fourier transform. So because of this reason, we are using frequency domain filtering for the periodic noise. And the periodic noise, it can be removed by transforming the image into frequency domain, then identifying the noise peaks. After that, suppressing those peaks using the filters and transforming back to the spatial domain. Now here, the steps of periodic noise reduction are, first what we'll do is we will take the Fourier transform, that is f of u comma v is equal to f of small f of x comma y. That is, this converts the image f of xy, small f of xy, into the frequency components. So periodic noise appears as symmetric pairs of bright dots away from the center of the spectrum. Now, second step is to identify the noise frequencies. Now suppose visualize the magnitude spectrum where the image components are concentrated near the center and the noise components appear as pairs of bright spikes. These spikes shows the exact frequency where the periodic noise is added. So that is how we identify the noise frequency. The third step is to apply a notch reject filter. Notch reject filter, it cancels out the frequency at the spikes locations, okay, which we have identified here in the second step. The general form of the notch filter is given by this equation, where this hk of u comma v and h of minus k of u comma v, these are the high pass filter transform functions whose centers are at uk and vk for this, and minus uk and minus vk for this transform. And here small k is nothing but the number of spike pairs. Now these creates small targeted holes or the notches in the frequency domain and removes noise, but these will preserve the image details. And the fourth step is you have to multiply the spectrum with the filter, that is g of u comma v is equal to h of u comma v into f of u comma v. So here this will suppress the noise frequencies while keeping the rest of the image intact. And the last step is to take the inverse Fourier transform by using this equation, that is g of xy is equal to inverse Fourier transform of g of u comma v. This gives the cleared image with the periodic noise. So these are the steps of the periodic noise reduction. One example for this is, suppose you are having an image with horizontal stripes. Now in the frequency domain, we will see two bright dots on the vertical axis, and we place notches on these dots. After the inverse transform, the spikes will disappear and the image remains unaffected. This is one example for about the steps of the removal of the periodic noise or the reduction of the periodic noise. These are the types of the frequency domain filters which we will study under the periodic noise. So first is the band reject filter, then you have band pass filters and the notch filters. So here what we have seen is in general the periodic noise reduction in frequency domain, it involves the Fourier transform, then detection of the noise peaks, design of the notch filters, and multiplying the filter with the spectrum and finding the inverse Fourier transform. And this method, it is effective because the periodic noise has well-defined frequency components, making it easy to isolate and remove. So this was about the introduction of the periodic noise in frequency domain filtering. In the next video, we will see what are band reject filters, band pass filters, and the notch filters.